I have tried to upload the recordings. These are all the recordings that we have, the new ones, but it takes a lot of time to get them onto YouTube or other platforms where we can all use them. So that's basically where we are stuck. But I will see how we can manage to get everything for you guys as well. Right. So to start off, this was part and parcel of the homework of yesterday, where we had to basically try and attempt if we can get the inverses of some of this matrices that we have seen over here. And I'm not sure how many attempted. And if there's any questions on this that we can quickly look at and try to at least move on from here. Please note, everything we are doing is basically linked to the next thing that we must cover. So if we don't understand the first part, then the next part will be a little bit more difficult again to understand or to comprehend. So that is basically why I spent time on the previous work, just to make sure that we get what is happening here and we can move on to the next part. Is there any questions? Any questions from you guys regarding the homework? That we can look at, and then we can proceed with the next topics, or just to explain something again, and then we can continue with the next one. I have to ask if there's any problems, because the next one that we want to cover today is solving simultaneous equations using matrices, and we basically are applying every single bit of thing we have learned from the beginning, so that we can at least solve simultaneous equations. How they ask the questions on matrices in the exam, this is basically the homework, okay? I've explained yesterday that we will give you matrices like this, matrix A and matrix B, and then we tell you the following at the bottom. Find the following, find A, B. We can even do, let me just write in another one just to show you. We can even add a D over here, and then we say find this B like this. My B doesn't look very nice. Just make it a little bit nice. So we can just ask you to find B like this. And as you can see, there's not a lot of information that's going on here. You basically have to know what is going on yourself. So what does this question, what does it mean? This question, what does it mean? What does this mean? And what does this mean? So you have to know what they mean by yourselves. And we will not try to make it as simple as possible, because we expect you to also learn the notations. That means how we write them in mathematics, and so forth. So basically that is what we are having. So give you a matrix like this. And another example which I wanted to try out today, hopefully if we have time, was if we let me just first say I wrap this out. If we give you a matrix like this, and we tell you that this over here is X, okay, and then we give you another matrix, which is now probably the B inverse or the inverse of B, and we tell you that that is basically equals to something. So, and then you are asked to find X. In this case, we will just say E, and then we put X at the bottom there, find X using whatever we give you in the inverse or something like that. So this is how we can play around with the questions, and we will expect you to be able to solve them. All right. So that is now one part where we have the inverse is given, but we are trying to go back to the original matrix, and you also have to know how we can get that. So that is also an extra bit of calculations that we have to do. And yeah, that is it. I saw there was another question 1B. I think that probably will be where is question 1B? I'm not sure where 1B is. Okay, is it this one over here? Are you referring to this question, Pinky? I don't know, it's Pinky. Okay. Show that when k equals to the root of 2, A is a self-inverse, and i.e. the inverse is the same as the original matrix, and then that is basically what we are saying. So if we put here k is root 2, basically you just have to note that it says that this element here is k squared, okay? So if we tell you that k is basically equals to the root of 2, then you take that k, you put it in here. So that means that element will now be root of 2 squared, which is just the same as saying it is 2. So it just says replace this element here with a 2, and then prove that the inverse it's a self-inverse, that the inverse is equal to itself. And that is basically what we have to prove over here. So you just replace this number with a 2, and then you check if you find the inverse of that one. And then you will see now, if the inverse, that means now, this is basically what they mean, that your A, right, is therefore equals to your A to the power of -1. So that is what they are asking you over here. So you have your A already, which the k squared is a 2 now. Then we just need to find the inverse and check if the inverse is the same as the A. And that is basically what they want you to do. We can try it out. We can try it out and then see what the answer would be. And that is basically what they want us to do. I need to take a screenshot because I want to do the calculations. Okay, so we are going to be doing a lot of calculations today. So I hope you guys will bear with me a lot. And also mind the noise in the background. We have, I don't know, all the children has decided today is a playing day where we live, so everybody is playing with everybody, so they might even come and run in here screaming somebody did not do what they're supposed to do. All right, so let me just rewrite A, because I already know that k is equals to the root of 2, and because that is equals to that, that means our new A will therefore equals to 3 minus 4, and I already said that this over here will be a 2 because we calculated it out, and minus 3. So one of the things that I've mentioned before is the questions that the matrices ask you, those questions are not straightforward. It means like you won't be able to see the answer. Like there's no way, there's no way that a answer of calculating this will be the same. Like you just can't see it clearly, and this is what we basically are talking about, where you have to do the calculation, and only from the calculations then you will be able to see it. So there's no way we can just do like lazy things as well. So also just to give an answer to the first question, all right, possible places where there will be no inverse. No inverse means that your debt must therefore equals to 0. So you just find a value that will make your debt equals to 0. So we will have 3 times -3. That will be the first part. Let's just do the debt already also. So we're also going to do the debt anyway. So I'll just do the first part, which is your debt is equals to, the first part will always be the same, 3 multiplied by -3. Okay. And then we say we plus it with the second part where we have
we minus
minus the second part. I wanted to put a k here, but let's put a 2 here, times -4. Okay, so obviously here we will get a -9 minus a -8, and this will become -9 plus 8, and this will give us a -1. So for us already in this part over here, we can already see that in order for us to make this thing more or less like equals to a 0, we need to change the whole number to something that will either give us a 9. Sorry, Rishua, you're muting you a bit. A 9 somewhere here, so that we have a -9 plus 9, which will end up to a 0. That will make the matrix mean that there's no inverse for this matrix. Okay, so we substitute values for k that will fit the equation, okay, to make it equals to 0. So basically this other part, sorry, this part over here, this half of the debt, okay, this half of the debt, if you include the minus sign, it's also okay. If you exclude the minus sign, it's dead. So this half must be equals to a 9, all right? So when it's a 9, it will be +9. That way it will be a 0. And if you have the k over here, k squared, you need to find out k squared times minus what, k squared multiplied by -4 will give us 9. So then you solve like a linear equation for that, and then it will be your answer. So I don't want to go into that. I'm just giving you what you need to do to answer this question over here. And then you can find out numbers for yourself there and see how you can do it. So the question that I was asked to do is this one over here, where we have to prove or show that a is equals to a -1. Okay, that is what I am currently doing. So I already have my debt for a. All right, we are first going to find a -1. So I have the debt, which is -1. So after the debt, I need my adjoint. So the adjoint, which I'm also just gonna write up here. Just fix this up quickly. So the adjoint, which will be equals to the matrix. So we have the flip -3, 3. It's closed already. And then we have the negative, so it will be a 4 and a -2. So that is the adjoint. So I have my determinant, I have my adjoint. Now I can find the inverse. Let me just quickly delete this part over here so that it doesn't get into our way. Okay, so we have our determinant, we have our adjoint. Let me just underline them. This is the two main parts that we will be using. And now we can do the inverse of the matrix. So A minus 1 is therefore equals to 1 over the determinant, which is minus 1. So it's 1 over minus 1. And then we are going to multiply it by the adjoint, which we have over there. And that is your minus 3, 4, minus 2, and 3. So if you look at this, all right, so the A, inverse of A, therefore, is equals to, this is just -1 times everything in the bracket. So -1 scalar multiplication. So -1 times 3 is just a 3. Okay, let's do that. -1 times 4 is just -4. -2 times -1 is just a 2. And -1 times times 3 is just a -3. And if you see that this is our inverse of the matrix, is exactly the same as the original matrix over here. So the original matrix, which was A, which is equals to 3 minus 4, 2 minus 3. So this is one of those questions where the inverse and the original matrix is equal to each other. So this is a self-inverse or self-inverse, they are the same, okay? And that is basically what it's explaining. So we just did the same things that we have over here. Notice also, remember, we can go on and test if this will, we said that the rule says that if you multiply A by A, the inverse, it should give you a -1. So you can also go and multiply it out to see if it can give you a -1. So yeah, wherever you have the determinant as a -1 or a 1, then you will have probably have the numbers inside here as whole numbers like we have here for the inverse. Also, if you have a determinant of either a 2 or even number, let's say we have a 2 here as a determinant, and we say the adjoint, all the adjoint numbers are like even numbers. For example, we have 8 minus 6, let's say 12, and let's say 2. So if you have something like this, where you have the determinant and the adjoint, determinant is a half, adjoint are all even numbers, you will also get whole numbers for your inverse, and that way you can also see that inside here we will not always just have fractions like we did before. So the previous examples were dealing with fractions, and that was quite a good example to do and also to look at for. So I hope I've answered that question for number 1B. But trust me, guys, looking at the questions like this, it's going to be a Greek language, like you will not understand anything. The only way to start to understand is by putting pen to paper, like start writing something down. When you start writing, it's like a surprise box. The moment you look at the surprise box, you don't know what is inside. Only when you start solving, unwrapping the paper, then you will now start to see, oh, it's the shape of a box, or it's the shape of a triangle. And then we will be able to solve the things that we have over there. All right. So today we look back at what we have covered. We have covered 1, we have covered 2, we have covered these 3 parts. We have looked at the 0 and identity part, and we have now looked at the determinant. We have looked at an inverse of 2 by 2. And today we are going to look at simultaneous equations by matrix method. Yes, that is basically what we are going to look at. So for the simultaneous equations by matrix method, I have to stretch because it's like one of those things where my brain is telling me, please switch on your teacher mode. It's going to be difficult to explain some of these things to you guys. So I have to basically get myself into that mode, where we can now start looking at the questions that are before us. So I haven't made a similar thing as I did with the other ones on the slideshow, where we will go through all of these things. So I just have a blank slide that I will be going through. And from that blank slide, we will be discussing many things as well. So this is just basically like the board that we have. And we will be looking at that. So I'm looking for, and yes, I have an example over here. I was just looking for an example that we can use, and then from that example, we will be basically answering all the questions that will pop up regarding this. So I also noticed that in the class, I did not do any of the what do we call it? I did not do any of simultaneous equations with you guys. It was supposed to be done in grade 10. And so I have no idea if we are all on the same page or something like that. So this is basically why I'm looking for an example that we can start. Okay. So we have simultaneous equations that we will be talking about. So that is basically what we are looking at. And I'm just typing it up here so that we can have a short demonstration of what we have. Let me use this one over here. I'll use a couple of examples of various types, and then we will see what we can do. There's one here that says x plus y equals to 12, and y equals to 3 plus x. That's one equation. I have another one here which says a plus b equals to 6, and 2a plus b equals to 8. And one more. Yeah, this one looks interesting. 10s plus 3t equals 12, and 3s plus 5t equals 20. All right. So basically, you can see we have 3 different sets of simultaneous equations. Let me just divide the board in such a way that we can see how we can attempt these questions. Okay, so now sorry, Loida, can you maybe just explain what do you mean by your question here? I don't understand what is how 2x plus 3y equals to 2. Maybe you can just make it clear for me? I am not following there. Oh, you wanted to give an example. Okay. So your example is just one equation. So you have to give like two of them that are correct. Right. So I've chosen these examples because mainly I'll explain why. Number one, over here we have X and Y. Over here we have A and B. Over here we have S and T. So also the letter variables are different, so it does not matter. Whatever the letter variables are, that is the first key that we have. And then on the one side we have what do we call it? Things we call coefficients. Now I have to talk about coefficients. All right. This we looked at. We looked at it when we did basic algebra. So I have to write it somewhere down. That's what I'm trying to do. So we have a coefficient. All right. So a coefficient is, let's make the light a little bit better. Is there anybody who can tell us what is a coefficient first before I even just give the answers? We should be able to know this by now. And that is why I chose this example. Anybody who knows what is a coefficient? Coefficient. You can unmute your mic, and when you unmute your mic, you can basically give us the answer. Unmuted the mic, give us the answer. What is coefficient? All right, it says we have 10 minutes left, but within that 10 minutes, we should be able to at least come up with a solution, guys. Anyone forgot? We forget. Okay. So I just opened up the following one so that I can show you what's going on regarding a coefficient, so that we are all on the same page or on the same space. All right. So over here, I have an example of what a coefficient is, so that we both know here. The number in front of the letter, that is basically it. So all the numbers in front of the letter, that is a coefficient. So the 4 here is a coefficient. The X is a variable unknown that we don't know. 7 and 5 are constants. Please note that a constant can also be a Y over here. Sometimes the Y variable can also be classified as a constant if it's alone, sometimes like that, if it's not going to change, right? So that is an example of a coefficient. And if you look at our examples that we have over here, talking about coefficients and the likes of it. So over here, we have no coefficients. So here is none, no coefficient, right? Okay, no coefficient. Over here, we only have one coefficient, one. And over here, we have a lot, like 4 of them, right? So there's also a difference in the coefficients that we have here for the various examples, right? So we've noticed that the letters change, the variables. Here's X and Y, the variables are A and B, the variables are S and T. The coefficients here, this one has no coefficients, this one has 1 coefficient, and this one has 4 coefficients. And those are also what we are looking at. So all of these things I'm mentioning okay, I don't know what. I forgot. Sorry about that. I accidentally clicked the slideshow, so the screen changed to black. Okay, so supposed to select. Okay, so so let me just go to the next one. That the black one. Okay, so that is basically what I am referring to by our coefficients that you have to also take note of 4 coefficients in this one and so forth. Okay, so having that in mind, we can also see why I also selected this one is that this example over here, it's not straightforward again, because the x and the y's are not both on the same side. It's different from the other ones where we have a and b on this side, a and b on this side, 10s and t on this side, and s and t on this side. So this is the difference in the examples that we will be looking at today. And we will be solving it using matrices, and hopefully that is why we have been doing all those previous topics to explain each one of the topics what we have. So simultaneous equations is like the final part of understanding matrices, that we can solve this using this. So we have various ways again in matrices itself to solve this. We have what we call a Cramer's rule. We have the Gaussian elimination method, and many other ways again. So for now, we will just follow a straightforward, simple process that we will use to solve this, and we will be explaining them step by step as we continue, so that we have something out here. So I think for the first one, you can solve them without matrices. You should still be able to solve each one of this. Okay, we can maybe, because time is a little bit up now, maybe if we can have some of you guys already try and find out what this one is and what that one is, and I will do this one without matrices first, just to see if we remember simultaneous equations. Okay, so I will be doing the first one, and somebody can try the second one and the third one. We have about 4 minutes left to solve each one of these ones, and then we just verify if our answers are correct. So we can start. I will also start, and I will explain, and you guys can just do it on a paper, and then afterwards give us the answers, and then we will see how it goes on. So we have x plus y equals to 12, and then I know x and y must be different answers. And the other one will be y minus x is equals to 3. Okay, that is what I need to know. So if this minus this, it's very easy to eliminate, but I don't want to eliminate. Let me just do the correct process. So the other one is x plus 3 plus x equals to 12. And then I have 2x plus 3 equals to 12. And then I have 2x equals to 12 minus 3. Then I have 2x equals to 9. And then I have x equals to 4.5. That's the first one. And y equals to 7.5. That's how I solved the two. So I solved mine in about 1 minute's time. And I get here a equals to 2. If a is 2, then b is 4. I don't know which method you used. Thank you, Rishua. And then what about s and t? I have 2 minutes for SMT. Is there anybody attempting SMT? This is just like a warm-up, just to get us into the simultaneous equations, because what is to come is going to be very, very difficult to explain in a long process. Anybody for SMT? We have about 2 minutes left, so let's quickly look at SMT. I don't see anybody with SMT, but I'll keep watching the chat. If somebody posts SMT, then I will see what happens here. Okay, let me quickly do this. Which one can we eliminate? This are all wrong. So which method can I use? I want to multiply everything on this side by 3, everything on that side by 5, so that I can have a 15 and eliminate t. So I will have 5, that means 50s plus 15t equals 60. And at the bottom it's by 3, so I'll have 9s plus 15t equals 60. Hey, this is a problem. This is a problem. But this is not going to work. So somebody's saying it doesn't understand anything. Okay, we have 1 minute left. So let's, I have to screenshot this before the thing goes down. Let us reconnect. And then by reconnecting, we will be able to see these things. Okay, I screenshot it because Zoom doesn't tell you you have 0 minutes left. It just disconnects the whole thing. And when it disconnects,